Okay, so this one tells me to first find f of g of x for the two functions, and then if possible, they want me to find f of g of 2 and f of g of 0. So let's start with what we're doing. So if I'm finding f of g of x, that means I'm finding f of g of x. So what is g of x? G of x is x minus 1. So what I'm going to do is I'm going to plug x minus 1 into the function f. So that's going to be the square root of not x, but x minus 1. So now I have found f of g of x. It's listed right here. And so now it tells me to find f of g of 2, if possible. So the way that I would do that, you could plug in 2 here. 2 minus 1 is 1. The square root of 1 is 1. So f of g of 2 is 1. And then it wants me to find f of g of 0. So now if I plug in 0 here, 0 minus 1 is negative 1. If I take the square root of negative 1, that's not possible. So this one does not exist. Okay, so right here it tells me to find f of g of x. So what this is saying is it's f of g of x. So what is g of x? G of x is x minus 1. So now I'm going to be plugging in x minus 1 to f. Yes, for x. So this becomes, instead of x squared, it's going to be x minus 1 squared. And I'm good just stopping right there. You can go ahead and distribute that out, right, if you did x minus 1 times x minus 1, but we don't have to. I'm just going to leave it as it is. And now it tells me to find f of g of 0. So this is f of g of x here. So I'm just going to plug in 0. So that's going to give me 0 minus 1 squared, which is negative 1 squared, which is positive 1. All right, so if we found f of g of x, we should have been finding f of 4 minus x squared, which gives us 4 minus x squared plus 2. So that would be 6 minus x squared for f of g of x. Questions on that part? Then they tell me to evaluate this at 0, and at 1. So at 0, I'm going to get 6. And at 1, I'm going to get 5. Questions? Now let's go the other way. Let's find g of f of x. To do it this way, that's going to be g of x plus 2. And so that's going to give me 4 minus x which is now x plus 2 squared. So I just plugged x plus 2 in where there used to be an x. So again, to me, that's fine. That's good enough end notation. You can distribute this, but that's not really the focus of this. So we can just leave it like it is. Now if I plug in for a 0, so I do that backwards. G of f of 0, that's going to be 4 minus 0 plus 2 squared, which is 4 minus 4, which is 0. So I plug in 0, I got out 0. And then let's do the same for G of f of 1. It's going to be 4 minus 1 plus 2 squared, which is 4 minus 9, which is negative 5. So notice how when we build the compositions, f of g is not the same as g of f. They give different values depending on the order of which you build your composition. So don't just think you can always do it one direction, it's the same thing. They're not. You get different answers depending on how you build the composition. And so let's just make sure that we're doing it correctly. F of g of x. So my function is 2x plus 5. Now I'm going to be plugging in f of g, which is 4x squared plus 1. That's going to give me 2 times 4x squared plus 1 plus 5. Then you're finding the other one. You're finding g of f. You're not finding f of g. So when I'm finding f of g, that means g goes inside of f. Right here, g of f is what you're talking about. If you write down g first. Did you get this answer? Well, then do whatever you want to do. You just wrote down all of g. That's fine. I mean, if you know what you're doing, I don't care how it looks like. I thought you were saying okay, on this one I actually would distribute. The reason I would distribute here is because when I multiply here, I'm going to get 2 that I can combine with this 5. So I'm going to go ahead and distribute. So that's going to give me 8x squared plus 2 plus 5, which is 8x squared plus 7. That looks a little bit nicer. So my f of g of x, I would get this. If you stopped here, I would count it. I wouldn't count anything against that. All right, but questions on A? Ready to go over B? Okay, so now I'm finding g of f of x. So my function g is 4x squared plus 1. But now I'm going to be plugging in f of x, which is 2x plus 5. So that's going to be 4 times 2x plus 5 squared plus 1. And I'm just going to leave that. Again, we could write 2x plus 5 times 2x plus 5, distribute, then distribute the 4. But don't have to, so I'm not going to. And then the question here, f of g of negative 1/2. That means I'm going here to f of g. And I'm going to plug in negative 1/2. So that would be 8 times negative 1/2, which is 1/4, plus 7. Whoops. I'm running out of space. That was not a good idea. That's 2 plus 7, which is 9. What you should get for f of g of negative 1/2. Okay, this tells me to find the domain of f of g for the functions f equals x squared minus 9 and g equals radical 9 minus x squared. So let's start by finding what the composition looks like. So I've got f of g of x. All right, well, f of x is x squared minus 9. So that means I'm finding f of g, which is radical 9 minus x squared. Which means I'm going to plug that in for x. So I've got radical 9 minus x squared minus 9. So what happens when I square a square root? Those cancel each other. And I'm left with 9 minus x squared minus 9. Well, 9 minus 9. Close. It's negative x squared. It's a reflection of my parent function. Okay, so I've built f of g of x, and I've found that it equals negative x squared. So now it asks me to find the domain. Huh? Yeah, find the domain. So what do I let the domain default to be? All real numbers. There are two possible problems I could encounter when I find the domain. Those are, I cannot divide by 0. I cannot take the square root of a negative. When I look here, could I divide by 0? No. Could I take a square root of a negative? No, not here I can't, right? Not on this one. So just from my composition, it appears that it should be all real numbers. But when we're finding the domain of a composition, we have to include the domains of the originals. And we have to put them all together. So this one gives me no restrictions. What about this one? Does this one give me any restrictions? No. What about G? Does G give me any restrictions?
Oh, yeah.
Yes, it does. We could have a square root of a negative error there. So in order to make sure I do not have a square root of a negative, I'm going to say what's underneath the radical must be greater than or equal to 0. It must be non-negative. And then we solve. So that tells me x squared is less than or equal to 9. All right, well, again, we don't like taking square roots of inequalities because they don't work out like they should. So if I take a square root, I'm going to get plus or minus 3. So we're going to treat those as our points of interest, negative 3 and 3. And our answer is going to be found by plugging in values. Do you remember doing this yesterday? We found the domain. So if I plug in negative 4, that comes from this section. Negative 4 squared is 16. Is 16 less than or equal to 9? No. So this section doesn't work. Let's try this section. What's the number between negative 3 and 3? 0. Okay? 0 squared is 0. Is 0 less than or equal to 9? Yes, it is. So this section worked. And then let's try this section. If I plug in a 4, 4 squared is 16. Is 16 less than or equal to 9? No. So this section doesn't work. So my answer is the things between negative 3 and 3. And we include those endpoints because it has an equal to sign. So my domain is between negative 3 and 3. And so when I combine all three of them, this one told me all real numbers. This one told me all real numbers. This one says only between negative 3 and 3. So since that's my only restriction, that's my final domain. But if I have multiple restrictions, I have to find where they overlap. like what we did yesterday. Okay, here I've got f is 2x plus 3, g is 1/2 x minus 3. It tells me to find each composition. So I'm going to start by finding f of g of x. So that's going to be 2x plus 3. And now that I'm going to plug in g of x, which is 1/2 x minus 3. That's going to be 2 times 1/2 times x minus 3 plus 3. Now what happens here? I have 2 times 1/2, which is 1. So that leaves me with x minus 3 plus 3, which is just x. So when I built f of g of x, I found the final value to be x. Cool. Questions? Let's go the other direction. If I found g of f of x. So my function g is 1/2 times x minus 3. But now I'm going to be plugging in f, which is 2x plus 3. So it's going to give me 1/2 times x, which is 2x plus 3 minus 3. Right, so I plug this in for x. Now, simplifying, look inside parentheses. I have 3 minus 3, which is 0. So those cancel. And then 1/2 times 2 is 1. So 1 times x is x. Hey, so when I built g of f of x, I also got x. This is a very special case of compositions that we're going to talk more about next section, where I built g of f of x and f of g of x, and they both simplified to be x. Are you close? Okay. So f of g of x, the function f is x raised to the 1/3. So now I'm going to be plugging in x to the 6th, which means I'm going to have x to the 6th raised to the 1/3. When I have a power raised to a power, how do we simplify that? You multiply, so that should be x squared. Not x2. X squared. Now if I go the other direction, g of f of x. The function g is x to the 6th. Now I'm going to be finding g of x to the 1/3, which means I'm going to have x to the 1/3 raised to the 6th. I have a power raised to a power. How do I simplify? Multiply. So 1/3 times 6 is 2. So I have g of f of x is equal to x squared. This is not a special case. So it is crazy that they ended up being the same thing, but that's not the special case we like. So when I look here, big picture, the inside, the inner function here is x minus 2. So I'm going to say the inner function g of x is x minus 2 because it's inside something that's already being squared. So now what's the outer function? The outer function is 1 over x squared. See where that's coming from? So if I built f of g of x, I would get h of x. G of x should be 8 minus x. That's what's inside. And so then what's left over? That's what f of x would be. You're going to have the cube root of x over 5. Absolutely. That's the outer function.